So let's look at some of the basic syntax of Objective-C. So the first thing to note here is that any C syntax is legal. I covered this before, saying it's a superset of C, but that means you can do anything that you want to do in C, that you could do in C. So there's two kinds of files. I think this is important to go over in Objective-C, is that you have basically a .h file and a .m file, and this is how you define your classes. If you're familiar with C++, it's very similar, where you have a .h, a header file, and you have a .cpp, which is an implementation file. In Objective-C, it's a .h and .m. So the .h contains a definition of the interface, which is different than the C# concept of interface. It's more of a prototype of pre-declaring what is going to be available in that class or what that class contains without the implementation of it. It's not, you wouldn't apply this kind of an interface to multiple implementations. It would just belong to one implementation. There's another method in Objective-C to create more of the C# style interface, and we'll cover that a little bit later. The .m file contains the implementation. So this is going to be the actual method definitions, while the .h file had the instance variables and pre-declaring what methods are going to be available. The .m is going to have those method definitions. And then another basic concept here is ID is basically a pointer to any object. So what I mean by this is that all of the types in Objective-C can be said to be ID, type of ID. Any type object is compatible with type ID. So let's look at some message passing instead of method calling in Objective-C. That's one of the key points here. Is it's a slight difference in the nuance, but instead of calling methods, we're going to pass messages, and those messages are going to be interpreted by the class, which is then going to invoke the method. So let's look at some of these examples I have here. So you can see you have these square brackets here that basically indicate those always go around a class and then the message that you're going to pass. So it indicates that you're passing a message. So I've got an object here and then a message that I want to pass it. That's going to be the method name, whatever you would declare as a method name. So that would be no arguments in the first example. In the second example, we're passing one argument. So we just simply have in our brackets our object, the message or method name that we're going to call, and then the argument, and then the close brackets. In the third example, you can see we're passing multiple arguments. And this is where it starts to look a little bit weird. What's going on here is it's basically allowing us to have named parameters. So the first parameter is the message, and then the second parameter is the name parameter for the second argument. So if we want to pass two arguments, we say object, the message name, first argument, the second parameter's name, and then the second argument. And it's actually pretty useful. If you look at the next example here, I'm showing you a example car class, and we might say car drive west at 20 miles per hour, at miles per hour 20. So that kind of makes it nice, a nice syntax that makes it almost like a sentence when you're passing messages. If you contrast this to other languages where you would do the object dot, that would be the comparison here, is that in this case we're passing a message. You can send yourself a message inside a class by just using self message and then the argument. And that's it for the message passing. We'll talk a little bit more about the differences between that and method calling a little bit later. But just to know that basic syntax, put it in the square brackets. So declaring a method. To declare a method, this is a little bit confusing at first. It'll take your mind a little bit to wrap itself around how to recognize these method declarations and understand them and to write them out. It took me a while to get into the habit of how do I do this. So here's a more complicated example to start off with, a multi-parameter declaration. If we look at the first part of this declaration, you have the return type, and then that dash before the minus sign is indicating that it's a private level method. It's a class level, object instance level method. If we put a plus there, it would indicate that it's a class level method. So that would be like a static method in C# or Java. So you first have your return value, which is pretty standard. Void is also valid for a method that doesn't return anything. And then you have the method name, add, which is also what will be kind of the named first parameter. And then after the colon, in parentheses, you put the type, and then the actual variable name in the method that you're going to use, just like a parameter name inside a C# or Java or C++ method. Then I have here the second named parameter, the name of that named parameter, and then again the type, and then the name of it in the method, the parameter name. And then you would declare the method body, and you could use the A and the B inside there. So it's a little bit backwards from what you're used to probably, and it takes a little bit, take a moment to digest this really and to understand how the syntax is working, because it's going to be critical in order to be able to write methods for your Objective-C. So to call the method, just to contrast that, we'd already covered this, but if you look at that exact method, if that were in a calculator class, we would just do in the brackets calculator add A and B, and that would call that particular method. So let's talk about using objects. So one thing to get out of the way here first is in Objective-C, when we use an object, we need to allocate that object and get some memory for it. In C# or Java, we probably would use new, and that would allocate it, and then we wouldn't worry about it. Well, in Objective-C in iOS, at least in version 4 and below, we have to worry about memory. So the first thing you can see here is declaring an object variable. You see I have my class, and then I have asterisk my class. And all this is just a pointer reference. If you're familiar with C or C++, you might be familiar with pointers, and it's a little bit of a scary concept, but it's really not that hard, especially in Objective-C. You don't really have to do a lot of strange things with pointers. For the most part, you just have to remember this one point, which is when you declare an object, declare it as a pointer, because a pointer is going to hold a reference to that object. So in this case, what that practically means is that when you declare your object variable, you just put an asterisk in front of the name of the variable. And then when you do assignment and everything else, you don't have to put an asterisk anymore. You just use it as is. So in the next line, you can see I'm assigning it to a new instance. So I'm just saying my class equals, and then I'm doing the special syntax here, which is basically I'm just chaining methods. We could have separated this out and said my class alloc, and then on the next line, my class init. But what we're doing here is we're sending the alloc message to the my class, and then we're sending a init to the result of that. It's just like method chaining that you would do in C# and Java. And this is just generally how it's done in Objective-C. It's usually done on the one line, and it's usually done like this. And we're just allocating memory and then initializing the class, because you never want to allocate the class without initializing it. So this just ensures that that happens. So then the result of that gets assigned to my class. So now the my class pointer is holding our instance we just created. And then we can do whatever we want to do with my class. And then when we're done, we just simply release my class. And we do that just by calling release, and that releases the memory to the system. So Booleans. So Booleans are different in Objective-C, as there's not really a type for Boolean. What there is there's a type def, which is a C concept, which is almost like a macro. It basically redefines something. It gives a new name to something. So bool, in its capital bool in this case, is just a type def for assigned character. And don't really need to understand what that means, but essentially in C, when you do evaluate something as true or false, like use an if statement, if statements just check for 0 or non-zero values. So what's happened here is bool is just going to hold a 0 non-zero value, and we have all these other definitions for yes, no, true, false. And you can see that you can use yes and no or true and false interchangeably. They're just defined as 0 and 1. So really all we're doing here is just assigning 0 or 1 when we say yes or no or true or false. So that's how you use Booleans there. Other than that, they're going to operate just like you would expect in any modern language. One important thing for us to note or talk about here is this whole foundations library. NS objects, basically. The NS stands for next step. And when you're programming in Objective-C, you're going to want to use these objects. They're kind of convenience Objective-C classes that make it easier to do things in Objective-C. So I've got a link here where you can see kind of the whole reference of all of the NS objects. But basically, they live in the foundation layer of the framework, and they provide you with some basic functionality for some convenience for things that you commonly do. So in iOS development specifically, one of the most common objects we'll use is NSString. And NSString is basically going to save us from having to deal with C strings. C strings are kind of a pain. They have to be null terminated. There's a lot of difficulty in working with those. Instead, we're going to use an NSString. And the way that you can use an NSString is you can allocate that string using methods that are on NSString, or you can do an @ and then in quote you create a string, and then the compiler will interpret that into an NSString. NSObject, all of our classes will derive from NSObject. It has some basic functionality, just like in C# or Java, deriving from object. NSArray, NSMutable array, these are just auto-sizing arrays. If you just declare an NSArray, it'll be immutable. If you declare an NSMutable array, you can actually add items to it and remove items from it. NSData is a chunk of data. It's going to be used commonly whenever we're passing data, like reading a file, passing data from a web service, things like that. A lot of methods will use NSData. So if you want to find out more about these NS objects, you can go to that link, and I've kind of highlighted the ones that you'll probably most commonly use. NS Dictionary probably is one also to be aware of as well. They kind of are going to give you that basic functionality that you might be used to in standard template library in C++, or in generics and collections in C#. Okay, so let's look at properties. Properties, just like they are in C#, you have them here in Objective-C. They're a little bit different, but essentially all they're doing, it's the same type of thing here, is they're preventing you from having to make a getter and setter. So we can declare a property in the interface file. We can use some syntax here. You see after the property, I have retain here. There's a couple of different things you can put here. For the most part, if you have an object, you're going to use retain. And what that does is it just simply makes it so that when your getter and setter are created, when the object is set, it ups the reference count. It takes ownership of that object. And then when it's released, when the object is released, the class is released, it releases that object. So it basically allows you to have the memory management built into the getter and setter. If you didn't have this and you just use a property, then when you set an object, like let's say someone allocated a string and then passed it to your class, when their class went out of scope, when they released their reference to that string, it would disappear from your class as well. So it's giving your class the ability to own that object that gets passed in. So you can see this is the basic declaration here. It's just like declaring a variable, except we have this property. I'm using of course a pointer here for the NS string. And then in the implementation file, .m, we just use this synthesize keyword, and that is actually what creates the getters and setters for us automatically. It will synthesize those methods as if they exist. And then you can do, now once you've done that, you can do just a dot syntax to access it. So here I'm grabbing the person's name out, and I'm saying, okay, I have a person object, I've got a property name on there, I just do person.name. You should be familiar with this from C#. It works the same way. Or you can assign it. Here we're assigning a person the name property's value to be Joe.